In this video, I want to talk to you all about the net change versus the average rate of change of a function. So one of the things that I hope that you're kind of seeing here is that leading up to the first exam, we talked very much about general properties of functions. What is a function? What do you do if you're told to evaluate a function? What is domain? What is range? And now we're actually settling in and talking about some contexts in which you would actually answer some questions about functions. So this is going to be the trend for a long time, is that we're going to start looking at specific questions that we can ask. And the first really interesting such question is the idea of change. So we talk about net change and average rate of change of a function. So I have two examples here. In the first example, a home was purchased for $135,000 in 1995 and then sold for $895,000 in 2017. So if I were to ask you about the net change of the price of this home, net change of the price of this home, you would simply take the price for which it was originally purchased and subtract that from the price at which it was sold. Okay? So, 135,000 is being subtracted from 895,000, and this is $760,000. Okay? Now, the average rate of change. One thing that we should talk about when we're talking about rate. So a rate, the word rate comes from the same exact place as the word ratio. So anytime that you see the word rate, you're dividing something by something else. So you always have to ask, like, okay, what are you going to be dividing by here? What kind of a number are you going to be dividing by? And so we're going to put in parentheses here that this is an annual rate of change. And after we do that, you can say, oh, well, what if I wanted monthly, right? And we can talk about that, although I won't do the example. So, yes, whoever it is that bought and sold this home, they sold it for $895,000 and they bought it for $135,000. So they are walking away with $760,000, but this took them from 1995 to 2017, right? So this very large growth in price, took place over the course of 22 years, okay? So we take the $760,000, which is the total amount by which the price of the home grew, and we divide that by 22 years, which is how long it took to grow by that much. And I'm going to round this to 2 decimal places since we are talking about money. So we're talking about, on average, $34,545.45 per year. Okay? So now, the word average is really, really important here. I'm not saying anything about what happened between 1995 and 2017. I'm only talking about 1995 and 2017. I'm sure you can all agree with me. You had the crash of 2008. There were all kinds of things that happened in those 22 years. So it is entirely possible that the value of this home fluctuated tremendously before ending up at $895,000 the day that it was sold. But as anybody who does investments will tell you, all of those are paper losses and paper gains. The only time at which you actually see gains is the moment that you sell. And on average, if you average out any fluctuations that happened over the course of those 22 years, this home earned about $34,500 a year. Now, let's look at example 2, and then we'll talk about these two kind of in a compare-contrast format. So here we have a home purchased for $850,000 in 2018 and then sold for $1.3 million in 2019. So the net change is going to be $1.3 million. So that's $1,300,000 minus $850,000. And that's $450,000. So if you are comparing net change, the net change was higher in the first example. In the first example, the value of the home grew by $760,000 from the time that it was purchased to the time that it was sold. In the second example, the net change is quite a bit smaller, right? It's $450,000. But look at the average rate of change. And again, we're still talking about an annual rate of change. So all of this happened over the course of how many years? Well, this home was purchased in 2018 and it was sold in 2019. So at most, this is a year. Realistically, this is where you might say, you know what, it might make sense to talk about months here, because it's entirely possible this home was not even owned by this person by a full year. But for our purposes, we're just going to assume an entire year has passed. And look, if you look at the difference between the purchase price and the sale price over the length of ownership, this home ended up making the owner $450,000 in 1 year. Notice I'm not talking about profit here. I'm purely talking about the change in the price per year. If you're talking about this from the point of view of like a real estate investing, then there are more questions to ask. Chances are, the first example, you're looking at someone who lived in a house until they could no longer, until it no longer made sense to live in that house, right? Maybe they had raised a family there, and then the kids were off to school, and it just doesn't make sense to live in that same house anymore. Their needs have changed, but this is a life lived, right? Like this is an example of a family that lived in a home. Chances are, they probably put money into the home as they lived in it. Whatever needed to get fixed got fixed. Maybe an upgrade here or there, a small remodel. But this was a family that lived in this home in some capacity, whatever that means. This was not pure investment, right? So the fact that they're walking away from it, having made money on the home, is just great. It's good. They were able to make some money on their family home. The second example is much more an example of a real estate investor, right? So if you see a situation like this one, this might be an example of a home that needs a tremendous amount of work, and it's purchased at a fairly low price in 2018. And then the developer or the investor puts a lot of money into it. Maybe a total remodel, major upgrades throughout the home, major refurbishments, maybe new roof, new electrical, major projects. But less than a year later, this home is now worth $1.3 million. This home can be sold for $1.3 million when it was purchased for $850,000. So this is a much more aggressive investment kind of scenario. And sure enough, even though the number of dollars that this investor is walking away with at the end, when you compare the sale price to the purchase price, the number of dollars is smaller than the long-term situation in the first example. The amount per year is more than 10 times as much. So example 2 is something you see when you're talking about an aggressive investment strategy. Example 1 is what you see when you're talking about a very risk-averse investment strategy, right? So this person, whoever these buyers were, they bought a great house that worked for them, and they were able to do so in a way that actually ended up making them a little bit of money at the end of their tenure in that house. But they were not doing this from an aggressive investment standpoint. In the second example, this is an aggressive investor. This is somebody who is going to have a fast turnaround of 1 year, and they're going to put a lot of money into the property and sell it substantially higher than what they bought. And so these two examples really illustrate the idea of net versus average rate of change. I want to finish this lesson by looking at it from just sort of an abstract mathematical standpoint. And for that purpose, I included this graph on the right-hand side of this page. So let's say that I have some function f of x, and this is its graph. And you can see I've already pre-labeled two values on the x-axis, a and b. A is to the left, b is to the right. So we know that inputs live on the x-axis, outputs live on the y-axis. So that means that this is f of a. And by that same token, we know that this is f of b. So the picture that I'm about to draw is a picture that you will see me draw over and over and over again when we're talking about net versus average rate of change. And that is this. I'm going to use a highlighter here. This difference is the net change. So I'm going to use color coding here. So the blue is the net change of f of x on the interval AB. And it is simply the difference of f of b minus f of a. Okay? If you want to talk about the average rate of change, we need to draw in a line. We need to draw in the line that connects a f of a and b f of b. So this line connecting these 2 points. And again, I'm going to use color coding here. So in green, the slope of that line, so the average rate of change of the function f of x on the interval AB is the slope of this green line. So what I hope you remember, but if you don't, here I am repeating it, the slope is the ratio of the change in the y-coordinates over the change in the x-coordinate. So that will be f of b minus f of a over b minus a. Now, notice that the average rate of change contains the net change in it. So once you have the net change, you're halfway to the average rate. All you're doing is you're taking the net change and you're dividing by the length of your interval, b minus a. So this is the beginning of our conversation of average rate of and net change. In the next couple of lessons, we'll look at how do you actually talk about the average rate of change of a specific function, and we'll look at a few examples. All right, that's the end of this lesson. See you later. Bye.